Being a data scientist is much more than simply using plug-and-play machine learning libraries. You have to really understand what the algorithm is doing first and foremost, and the way you do that is by gaining an understanding of the underlying maths. To be a high caliber data scientist, you need to understand the fundamental maths. That's just a brutal truth. However, the maths you need is not PhD or master's level. It's typically the maths you learn in your final years of high school or in your first few years of certain undergrad degrees. So, in this video, I'm going to explain to you the maths you actually need as a data scientist and some useful resources for how you learn it. Let's get into it. Data science itself is quite a big field, and it's also still not clearly defined exactly what a data scientist is. So, if you're a data scientist at one company, you may be doing completely different work to a data scientist at another company. And what this means is that the maths required for different roles and different companies will ultimately vary. However, there are a few key concepts and core ideas in mathematics that I think every data scientist should know, and will likely cover anything you'll get in certain job descriptions or any interviews you may have. Now, it's important to mention that in this video, we'll cover things that are mainly used for junior or entry-level positions. It's not for people who want to be a machine learning researcher at OpenAI, for example. That's a completely different kettle of fish, and personally, I have no experience with that, so I can't really speak on it. So, in general, there are three topics you want to cover, which are statistics and probability, linear algebra, and calculus. Those are the three main mathematical fields that are used frequently by data scientists, and the ones I use pretty much day to day. These fields individually are ginormous, and people dedicate their whole careers and basically life to studying them. The goal of this video is not to, learn everything in these areas, but just the things you need to know and the core principles that you will use frequently as a data scientist. Anyway, let's dive into these key concepts, and I'll let you know what you need to know about it. Each section will be broken up into what to learn and how to learn, so you can easily tailor your learning for your data science roadmap if you have one. In my opinion, probability and statistics is probably the most important one out of the three, as it's the one you frequently use the most, and it's also the most applicable to the field. Like I just said, probability and statistics is a very large field, and there's a lot of active research going on. But we could probably break down what you need to know in this area to 5 or 6 key principles. Now, the first one is descriptive statistics, and this is all about summarizing and getting some key information from the data. So the things you should really learn are mean, median, mode, variance, standard deviation, quantiles, just anything that summarizes data. And also very useful to have some knowledge about how you visualize it. So things like box and whisker plots, bar charts, line graphs, pie charts, the list goes on, but you get a picture. Just things that you would frequently use to show stakeholders or people what your data really means under the hood. The second one is to have good knowledge of some of the most common probability distributions. So things like normal, Poisson, gamma, binomial. These distributions come up a lot in data science, and they're also very important for any EDA project you do, and also any modeling, because in modeling, you gotta know what distribution your data has, so you can fit the correct algorithm to it. The third area is probability theory. Now, machine learning, even though it's called machine learning, a lot of it comes from like a statistical learning theory. And so if you know probability theory very well, you will also understand machine learning very well. The areas you should learn for this are basically things like maximum likelihood estimation and Bayesian statistics. These are just all-encompassing statistical knowledge that you should have as a data scientist. The next one is hypothesis testing and confidence intervals. So these come in handy for A/B tests. And A/B tests are used pretty much everywhere in data science and analysis and marketing. And so it's a very useful skill to know. Hypothesis testing is a form of just testing significance, or if your result is statistically significant. Like I said, it's used everywhere, so it's something you should really develop and understand. The things you should learn are basically Z-test, T-test, chi-square test, and what are confidence intervals. The final one is the idea of modeling and inference. Now, like I said, machine learning is pretty much based on statistics. And so with that, you get things such as linear regression and generalized linear models. These are two quite famous modeling techniques that pretty much lay the bedrock of most of the machine learning algorithms. So learning those will give you a really good foundation for anything else you do from there. There are of course many other areas to explore within those subdomains, and if I listed out everything you need to know in statistics, it would be pretty exhaustive, and to be honest, it would be a very long video. However, Wikipedia has got a great article that gives you a link of the whole field, so I really recommend you check that out if you want a really big overview of what statistics and probability looks like as a whole spectrum of the domain. Probability and statistics is such a big field, and so there's so many resources out there for you to learn from. However, there are a couple that I really recommend, and are basically just a one-stop shop for everything you probably would need to know in the field for data science. The first one is the textbook Practical Statistics for Data Scientists. Now, I can't recommend this book enough because it's basically what we're after. It's a statistics book exactly designed for data scientists, and so it will cover all the things we will need to know on a day-to-day basis and all the things I just listed in this video. If you'd rather learn from a video format, then I really recommend Free Camp's video on statistics. It's about 8 to 10 hours, but it will give you a rundown of everything I just mentioned in this video that you need to learn about statistics and probability. Calculus is the heart of how machine learning algorithms actually learn. The optimization process of machine learning is done through calculus, so it's really essential you understand the fundamentals and what calculus is really trying to do under the hood. There are two main areas for calculus: integration and differentiation, but let's break them down a bit further. Differentiation is all about breaking something down into small pieces and seeing how it reacts to little changes or rate of change. Now, I appreciate that sentence may seem a bit arbitrary to you right now, but I promise you, once you start studying and basically understand what differentiation is, it'll make a lot more sense to you. The things you should learn are obviously what is differentiation and what is derivative and what do they mean. Learn the derivatives of common functions, things like sine, cosine, tan h, the exponential, and basically why are those derivatives the way they are. What are turning points and why are they important, and how do maxima and minima relate to them. Learn differentiation operations such as product and chain rule, which are used a lot, particularly for gradient descent and backpropagation, which are used pretty much in every machine learning algorithm. Understand partial derivatives and their role in multivariate calculus. Again, this is the lifeblood of gradient descent, so it's something you should really be familiar with and really understand. Be able to understand the difference between a convex and a non-convex function. Again, this is really important for optimization problems and being able to understand if the solution you find is indeed the best one. And finally, make sure you learn about Hessian and Jacobian matrices. These are used throughout deep learning, so I really recommend you learn them. Now, let's move on to integration. And integration is arguably used less in data science than differentiation, but it's still equally as important. So, like with differentiation, you should begin learning integration by basically understanding what it is, what's its purpose, and how does it work. Learn the integration of common functions. Again, sine, cosine, the exponential are the common ones you should know. Different integration operations, such as integration by substitution and integration by parts. How do you do integration calculations for volume or areas? And finally, this concept is a bit more advanced and not really a requirement, but understanding what Fourier series are and its applications. Now, the way I recommend you learn this required calculus is through the textbook Mathematics for Machine Learning. Arguably, this book might be a bit overkill and it has a lot of more in-depth and quite advanced topics in there, but if you really want to learn everything in that calculus section, then your knowledge of calculus will be excellent. Likewise, Free Camp has a Calculus 101 course, so feel free to watch that if you prefer a video format for your learning. And so the last topic is linear algebra, which is all about how matrices, vectors and scalars work in linear spaces. Right, so the things you should learn in linear algebra are vectors. So what are vectors? How do you calculate the magnitude, dot product, angle, orientation, things like that. Just basically how vectors work and what they represent. Then learn about matrices. Now, matrices are basically just big, array structures you can think of if you come from a computer science context, and they hold data. So a data set with n features and m rows is basically an n by m matrix. So it's really common and really used a lot every day, even if you don't think about it. After you've learned about matrices, I'll then move on to their operations and transformations. So things such as the trace, transpose, determinants, the inverse, just how matrices work and some of their baseline transformations that you'll come across frequently as a data scientist. For example, finding a matrice's eigenvalues and eigenvectors is the bedrock understanding you need to really grasp what's happening in principal component analysis, which is a very common algorithm used in industry. And finally, the last topic you should cover in linear algebra is systems of linear equations. This is used primarily in optimization problems where you have multiple objectives and constraints, and your goal is to find a solution to those multiple equations. You should learn techniques such as row reduction, elimination, and Cramer's rule. To learn this linear algebra, I again recommend the Mathematics for Machine Learning textbook. It's amazing, and like I said, probably goes into more detail than you need, but it gives you a really good and solid understanding of the mathematical concepts in a really detailed way. There is also an excellent Coursera course called Linear Algebra for Data Science and Machine Learning. It basically does what it says on the tin, and I really recommend you check that out if you like a course structure for your learning. And finally, like with all the other sections, Free Code Camp have got an excellent video on linear algebra if you prefer video format learning. I know maths can be scary and some people may not be naturally good at it. But like I said, the maths is not an extraordinary high level. It's, yes, can be kind of the entry level for most university courses, but I truly believe most people can learn it, give it enough time and enough effort. The three key areas you need to know are statistics, linear algebra and calculus. Having a really good understanding of these three fields will set you up for success later on in your career, so I really recommend you invest time right now to learn them thoroughly and really understand what's happening under the hood of all of these areas. If you enjoy this video and want to learn how you can become a great data scientist, then I highly recommend you check out my newsletter, Dishing the Data. Every week I give tips and advice of how you become a better data scientist and learnings I'm having in my own career that may benefit you. I will link it in the description below in case you want to check it out. Make sure you like, comment and subscribe, and I'll see you in the next one.